Hello everyone, I'm Mrs. Page and welcome to the first physics GCSE lesson. So firstly, I would like you to make sure that you have got a pen and a piece of paper or a notebook and somewhere to work, somewhere clear to work, and ideally with no distractions. You also might need a calculator. So what I would like you to do is, if you don't have those things, then just pause the video now and go and get them, and then you can resume. All right. Fab. So this first lesson is going to be looking at the difference between a vector and a scalar. So in science, we have two different types of quantities, and we call them vector and scalar. And there is a do it now for you to have a go at. So you can see in the picture here, a skier is traveling down a slalom, so traveling down a ski course. Looking at that picture, what is the distance that they have traveled? And which one is the displacement that they have traveled? And can you think what the difference might be between those two? So don't worry if you can't come up with a proper definition yet. We're going to go on and have a look at that in a moment. But can you give any ideas of what the difference is between those two values? Could you describe that? And then if you're feeling extra confident, could you add as many of the keywords below, so these keywords in the blue bar just here, add as many of those as you can to your comparison. All right, so if you pause the video now and spend a few minutes just having a go at those 3 or 4 questions. Excellent, well done. So looking at this picture, it's got the distance and the displacement labelled. Okay, so the distance is this line here, and the displacement is just here, like from A to B, just a straight line. Okay, we're going to look in a moment at the difference between those two values. So what you can do for that question is just wait a moment and until we get to the definitions and see how close your description of what the difference is between those two. All right. So distance, so that's this wiggly line here, so the total distance that the skier travelled. Distance is what we call a scalar value. It only has a magnitude, which is another word for size. So it only has a magnitude or size, but it has no direction. Okay, and some other examples of scalar quantities are mass, distance, obviously, that we've just looked at, and speed. All of those have just got a magnitude, a size, and no other quantity to them. The displacement, which is this line here, which was 8 meters, the displacement is what we call a vector. A vector has a magnitude and a direction. So it's the distance covered in a straight line. All right, so you can see here that this displacement would have a magnitude and a direction. Okay. So looking in a bit more depth at distance and displacement then. So I've got a map here which shows a journey. All right, and this journey is from London to Lincoln. So someone's travelled up the country, someone wants to travel up the country from London up to Lincoln. And there are 3 lines on this map. So the first dotted line is via helicopter. The red line is via train, and the purple line is by car. So these are the 3 different journeys that somebody could make if they wanted to make this travel. Which of these transport methods has got the same distance travelled as displacement? Which of those has got the same distance travelled as displacement? I wonder if you can guess. Excellent. I'm sure I heard loads of you shouting out the right answer. So yeah, the helicopter journey, as you can see, is a straight line and it's got the same distance travelled as the displacement. The other two journeys don't have a straight line, so the distance that they are travelling would be different to the displacement. So the other question says, how is displacement related to the phrase, as the crow flies? So I wonder how many of you have heard this phrase, as the crow flies. It's basically meaning a crow, because it can fly, can travel in a straight line. So if it wants to go somewhere, it would travel directly there. So its distance would be the same as its displacement. Okay, so if a crow took on this journey, it might have to stop for a few rests, but yeah, its distance would be the same, similar to this straight line here, and so therefore its distance would be the same as its displacement. So here are some scalar quantities and some vector quantities that I've put into two lists. Remember, a scalar quantity only has a size or a magnitude, and a vector quantity has both a size, so magnitude, and a direction. Okay, so scalar, just magnitude, vector, magnitude and direction. What I would like you to do is draw a quick table, try and draw it neatly if you can, with scalar quantities in one column and vector quantities in another. And then I would like you to pick 3 or 4 of each of these quantities from the scalar list and the vector list and put them into your table, please. Okay, so you are drawing up a table with scalar quantities in one column, vector in another, and choosing 3 or 4 of these quantities to put in your table. Okay, so if you pause the video now and have a go at that for me, please. Fantastic, well done. Also, what I would like you to do, please, is here in these red boxes, we've got the definition of scalar and the definition of vector. What I would like you to do is copy out those definitions for me so that you make sure that you understand them best as possible and so that you can use them for revision. Okay, so again, pause the video now and have a go at writing those out, please. Fab, thank you. Okay, so here are some practice questions to help us have a think about the difference between scalar quantities like distance and vector quantities like displacement. So for each of the examples below, state the athlete's distance moved and their displacement. So firstly, Usain Bolt runs the 100 meters. Okay, so here's the 100 meter track here. Oh, here we go, start, finish. He runs 100 meters. Kelly Holmes runs the 800 meters. So she is going all the way around the track. All right. So for each of those athletes, can you state the distance they've moved and their displacement, please? And then number 2, again, what is the distance between scalar and a vector? Okay, so pause the video now, have a go at those. If you're not quite sure, then feel free to rewind the video so that you can have another look, or feel free to have a look at BBC Bitesize, about their page on scalar and vector quantities. There's plenty on there describing the difference between scalar and vector, so the difference between distance and displacement. You can do that and then come back to this question and have a go. Okay, but if you pause the video and try and give that your best attempt. Brilliant, well done. Okay, so Usain Bolt, remember, he starts here and he runs 100 meters. So he's ended up 100 metres away from where he started. So the distance that he ran would be 100 metres. Also, the displacement, because he would finish up over here, 100 metres away from where he started, his displacement would also be 100 metres. Okay, so for A, Usain Bolt, distance run, 100 metres, and displacement also 100 metres. For Kelly Holmes, she is running the 800 metres. So remember, she started here, she ran all the way around the track, and she ended up back here at the start line. Okay, so when we look at her distance and her displacement, the distance she ran was 800 metres. So if you measured that out with a trundle wheel, she would have run 800 metres. However, her displacement is 0 because she would be standing in the exact same place that she started. Okay, so her displacement would be 0. And number 2, the difference between a scalar and a vector quantity. Hopefully you've learnt this by now. So a scalar has only a magnitude or a size, but a vector has a size and a direction. So if you mark your answers, so just tick what you got right, and if you correct the answers that you got wrong, then that will really help with your learning of this topic. Okay, the last thing that we have for this lesson is a 6-mark question. So these are really important to practice because they come up in every single GCSE paper. So we like to practice these all the way through our science study at school. So this one says, a satellite is in orbit above Earth. It moves at a constant speed, but its velocity is constantly changing. Can you explain why? So explain why a satellite is in orbit above the Earth. It moves at a constant speed, but its velocity is constantly changing. Okay, so that should say explain why. So in your answer, refer to the difference between scalar and vector quantities. Okay, so remember, speed is a scalar quantity. It only has a magnitude, but velocity is a vector quantity. It has a magnitude and a direction. So have a think, when the satellite is moving, even though its speed is constant, its direction would be changing, wouldn't it, as it spins around the Earth? So have a look at that. See if you can put it into a 6-mark question. Don't worry about copying this question down. I will be putting this question on Showbie. So what you'll need to do to answer it is go to www.showbie.com, enter the class code for physics, which is just there. So if you want to pause and just write that down now. And on Showbie, there will be this 6-mark question for you to have a go at answering. And if you submit your answers to me, then myself or one of the science teachers will mark it for you and give you some feedback. Okay, well, that's the end of this lesson for now. There will be more physics lessons to come. So well done today, and I'll see you soon.